Turkey!
Can I go to the restroom?
Sure. Radicand. I would have said it out loud, Brianna, but I've decided to not bother trying to talk over people who don't care enough about math. Coefficient means what?
A number.
It is a number that does what? It's beside a variable. And what does it do to the variable? Multiplies it. So, if it's a mixed radical, there must be a coefficient 3 with the radical. That's an entire radical, no coefficient. That's a mixed radical, coefficient. What does this mean? 3 times the square root of 96. Everybody cool to there? All right. Now, up until today, every time you were faced with a square root or a cube root, you got out your calculator. And more often than not, your calculator gave you an irrational answer, didn't it? And we don't like irrational answers because they don't actually exist, do they? You can't put them on a number line because they never end. Okay? Math guys don't like them. Just like math guys don't like pi. Remember how when you first saw pi, your teacher said use 3.14. And you said, yes, Mrs. Macrumble, and you did your work and you got an answer. And it never had more than a couple of decimal places because you used 3.14, yes? Then in grade 8, your teacher said use the pi button. Now all of a sudden your answer's at all kinds of decimal places. And then when your teacher marked it with you, you would round them wrong, and your teacher in grade 7 probably said that's wrong and took marks off because you were rounding poorly. Then your grade 10 teacher, who loves you more than anything, said, don't even bother with rounding. Just go ahead and leave it as pi. Right? Then you didn't have to argue. You didn't have to be like, I don't remember how to round. You could just leave it as pi. The real reason for that is because 96 pi is an exact number. We don't worry about the decimals. Same thing in radicals. If you were to punch that into your calculator, you would get an answer of 8.5-ish, right? We don't like that because it's not exact. So what we're going to do is we're going to talk about how to make that an exact answer with no decimals. All right? I'm going to give you a hint. It has to do with two things you already know. One is prime factoring, which we did a couple of days ago. And the second thing it has to do with is breaking the radicand up. So, in that very first question, the square root of 72, what is the radicand? 72. Excellent. So, knowing what we know here, we've got to break that radicand up into little pieces, yes? I'm going to do 3 things. You can do any one of these 3. Most of you will start with the first thing I do. Some of you will graduate onto the second thing I do. And some of you will graduate onto the third thing I do. Please remember, the first thing I show you always works, but it will take the longest. But it will always work. So, let's do that. We're going to break the radicand up. How do we break the radicand up? We need to break it down into what? We need to break it down into factors. So let's take our 72, and I'm going to do this one in black. This is method 1 that always works. I'm going to take that 72, and I'm going to break it down. What are some factors of 72? 9 and 8. Can we stop there? No, because those are not prime factors. What are the next ones? 3 and 3. What about this one? 2 and 4. Can I stop at the 4? No, I'm going to get 2 and 2. Now, do I have my prime factors? Excellent. So the square root of 72 is also the square root of 2 cubed times 3 squared. Yes? Because I have 1, 2, 3, 2 cubed, and 1, 2, 3 squared. Does everyone see that? Excellent. Now, there's another part to a radical, isn't there? There's this little number right here. What number should be there, but we don't write it in radicals? 2. Which means I'm looking for groups of factors that are how big? Groups of 2. Is there a group of 2 2s? Yes, I actually have 3 of them, don't I? So can I take 2 of them out? Excellent. So I'm going to bring 2 of them out from under there. What did I leave under there? A single 2 and 3 squared, yes? Is there a group of 3s I can get out? How many?
2.
I can get out 1 group of 2, right, Jake? So I have a 3 out here, a 2 out here, and what did I leave under there?
2.
A single 2. Now, numbers out in front are coefficients. What do coefficients do, Jack? So what do I do there? Multiply. What's 3 times 2? 6 root 2. And that is my final answer. That is the longest way to do this. But it always works, and you don't have to memorize anything except division. Let's move on to the middle distance. Number 2. In number 2, I'm going to use those same factors. But I'm going to stop at different places. 9 and 8 and 4 and 2. Is everybody cool with that? So this means the square root of 72 is the same as the square root of 9 times 4 times 2, yes? What is the square root of 9? 3. So what comes out? 3. What is the square root of 4? So what comes out? 2. Does 2 have a square root?
No.
So it stays under there. What do I do with the coefficients? Multiply them. 6 root 2. That is version 2. I can stop anytime my branch ends at a perfect square when I'm doing square roots. Everybody cool? You can all see how it works, right? The third method, which is the fastest way but requires you to have the most memorized stuff. Is there a factor of 72 that is a perfect square? You said it earlier. 36. Isn't this 36 times 2? Why can I stop there? Because that is the square root of 36 times 2. What is the square root of 36? 6. So what comes out? 6. What did we leave under there? 2. And notice all 3 get you the right answer. Do I care which you do? No, I don't. Do I care if you take 100 hours to do one question? Yes. So if you can use the speedy one on the smaller numbers, should you?
Always.
Let's have a look. Square root of 99. Let's break it down. First of all, it's not a perfect square, is it? So we got to break it down. Let's break it down. If I break it down all the way, what do I get? 3 times 33. Then what? Then what? 3 times 11. Is there a group of 2?
Yes.
So what comes out?
3.
A 3, and I leave an 11 under there. That's doing the way that always works. What about the blue way? 99 is... Yo. No, because we're taking out a group of them. 99 is 9 times 11, isn't it? Can I stop there? Because 9's a perfect square. What's the square root of 9? 3. What comes out? 3. Does 11 have a square root?
No.
So it stays under there. Picking up what I'm putting down?
Yeah.
Great. Let's look at 75. I can break it down into what and what? 5 and 15. Can I stop there? No. Because that's 5 and 3. Is there a group there? What is it? 2, 5. So what comes out? What stays under there? 3. Can I do that a shorter way, like in green? What is 75? 25 times 3, isn't it? What's the square root of 25? So what comes out? 5. What stayed in? 5 root 3. Why does this help? Does it make it easier, or does it just make it quicker? Makes it quicker. But to do this, you have to have some perfect squares memorized. If you're bad at memorization or refuse to memorize, do you have to do this math? No, it just makes your life easier. 80. How can I break it down? Pardon? 20 and 4. Can I stop at the 4? Why? It's a perfect square. Excellent. What about 20? Can I break it down again? Into what? 5 and 4. Can I stop at the 4? Why? Perfect square. So what I have there really is 4 times 4 times 5. Yes? Do I have a pair? What is it? 4. What did I leave under there? 5. If I was good at my times tables, like, say, Mr. Myers, I would recognize that the root of 80 is the same as 16 times 5. What's the square root of 16? 4. So out comes 4, and what stayed under there? 5. Was my way faster? Did I get the same answer? So does it matter which way you use? No. 300, what's that? Huh? You could do 50 and 6. You could do 103. Why is 103 better? Why, Sam? Why is it faster? What's the square root of 100? 10. So what comes out? 10. What stayed under there? 3. Nick, your new desk is the back corner. Pick up your stuff. Go. You got 5 seconds or you're going out in the hall. 5, 4, 3, 2. Good. Get moving. Faster. You're slowing up 30 people. You know who is more important to me. There you go. TJ, your next move is out in the hall, but I think without him there, you may actually stop. Stop it. $63, what am I going to use? Why 9, Mike? I mean, James, your middle name is Michael. Why?
Because you can square root 9.
Because 9 has a square root. 9 times 7. What's the square root of 9?
3.
So what goes out?
3.
3. What stayed under there? 7. What about 32? So Sam says use 16 and 2. What's square root of 16? 4. What stayed out? Or what stayed under there? 2. Now, this is problematic. Why? Because a great many of you aren't familiar with your 16 times table, are you? Few of you probably saw 16 right away. So a few of you probably needed to go 8 times 4, right? And then you stop at 4 because it's got a perfect square. Then 2 times 4. Stop at 4. So you know that's 4 times 4 times 2. Is there a group of 2?
Yeah.
So what comes out? 4 root 2. Do I care which way you do this? No. Great. What's 363?
11 and 33.
11 and 33? According to Jack. Now what?
3 and 11.
11 and 3. Is there a pair? So what comes out? 11 root 3. Now, Mr. Myers happens to have his perfect squares memorized. 363 is 121 times 3. What's the square root of 121? 11. What did I leave under there? 3. Does it matter? No. Is everybody cool with basic simplification? Do you feel you could do it by yourself? I do not believe you. Everybody do this one. The root of 96. Go. You got 3 methods to choose from. Choose one of them. Don't yell out an answer. I didn't say you were. You seem to have a guilty conscience.
Why?
In all my years of teaching math, I have found that the middle one is the one most kids get. Most kids don't need to do factoring all the way down. A lot of kids don't have their perfect squares memorized very high. So they like the one in the middle. Okay? So I am going to do that one. 96 is 24 and 4. I'm going to stop there because it's a perfect square. 24 is 6 and 4. I'm going to stop there because it's a perfect square. So the square root of 96 is the same as 4 times 4 times 6. What comes out? 4 root 6. Now, I know I should have given you more time. Don't get me wrong. I understand that. But I have a reason. Okay, I got some stuff I want to get through today, and I got to leave 10 minutes early. Can everybody do it?
Yes.
If you didn't actually do that one because I ran out of time, did you at least start on the right path? Everyone? You break it down, you find your pairs. That's all you got to do. Let me ask you this. What if I wanted the cube root of 96? What size group would I be looking for? Group of 3. Would any other rules change? No. Okay, let's move it along, little doggies. Page 97. Write as an entire radical. What does that mean? I need... I only need a radicand. So no coefficient. So which number isn't allowed in the first one, the 2 or the 5? 2. The 2's not allowed. If there's 1 2 out there, How many 2's lived under there? 2 of them. So it would be 5 times 2 squared, which would be what? 5 times 4, which would be 20. That's the answer I'm looking for. Everybody cool? Okay, what would this one be? If there's 1 7 out there, how many are under there? 2. So it would be the square root of 29 times, which is 29 times 49, which is what? 1421. My computer's frozen. I was going to show you a trick right here. Oh, there we go. 29 times 7 squared, which is 29 times 49, which is square root of 1421. What little number should be the index there? 2. What little number should be the index there? 2. Please notice, 2 squared, what went back under there? 2 squared. 7 and 2, what went back under there? 7 squared. So what's going back under here? 4 times 6 squared, which is 4 times 36, which is 144. What's tricky? What's going back under here? Just 5. Why? Because there's no brackets. So it's negative 12 times 5 squared, which is 12 times 25, which is root 300. Is everybody cool? Okay, now, are square roots the simplest radicals to deal with? Yes, because they're the smallest group of factors, right? Do you think it will change if we change the group size? I've already asked you once. You know that it won't. Let's look at this question. How does cube root of 54 differ from the square root of 54? I need a group of 3, yes? So if this was the square root of 54, I could stop my factor branches at squares, right? Like 16 or 4 or 9, correct? But now it's a cube root, so when can I stop my branches? I could stop at cubes. Everybody with me? Let's do this the long way first. What does 54 break into? Most of you are going to say 9 and 6 because you know your times tables. What does 9 break into? 3 and 3. What does 6 break into? 3 and 2. What do you see there? A group of 3. How big a group am I looking for this time, Jake? 3. So what comes out? A single 3. What stayed under there? 2. Everybody cool? It's exactly the same thing, but we're looking for a group of 3 instead of 2. Can I shorten it? I can shorten it because 54 is 27 times 3, yes? 27 times 2, yes? Right? 20 times 2 is 40, 7 times 2 is 14, 40 and 14 is 54, right? Can I stop there? I can if I know that the cubed root of 27 is 3 and I left the 2 under there. Because it's cubes, I can stop my branches at any perfect cube. Is everybody good? All right, so let's look at 144. We all know the square root of 144 is 12. But I don't want the square root, do I? I want the cube root, so I need groups of 3, right? So we know that 144 is going to break down into 12 and 12, yeah? What's 12 going to break down into? 2 and 6. 2 and 6. 2's are stopping. 2 and 3. 2 and 3. How many 2's do I have? 4. Cubed root of 144 is the same as 2 to the 4th times 3 to the 2, yes? Can I get a group of 3 out? Where? I can get out a single 2. How many 2's did I leave under there? 1. How many 3's did I leave under there? 2. So what is 2 times 3 squared? 2 cube root 18. Is everybody cool with that? It's the same thing. We're just adding a bigger group, right? Do our rules change? No. All right. What's weird about C? So what does that mean, Tasha? I have to have 4 factors. Do I change my rules? I break it down. If I know my times tables and I'm good at, not good, but I have practiced a lot, I might know some perfect 4th roots. Who in this room do you think knows some perfect 4th roots off by heart?
You.
Me. How many of you do you think? Maybe a couple, right, Josh? So we're going to have to break this down, aren't we? 128 is what? How are you going to break it down? Who chooses? You do. 2 and 64. I'm going to stop at 2 because it's a prime number. What about 64? 4? 4 and 16, right? Can I stop at either of those? No, because I don't know 4th roots. 4 breaks down, though, into what? Computer's frozen. Stop right here. 16 happens to have a 4th root. Because it's 2 times 2 times 2 times 2. If you're going to memorize anything beyond cube roots, I would recommend knowing your 2's. 2 squared, 2 to the 3rd, 2 to the 4th, 2 to the 5th, 2 to the 6th. I would recommend knowing your 2's, but you don't need to. I'm going to stop there. You need lots of 2's, really, though, don't you? I'm going to stop there because I know. So what is the 4th root of 2? Of 16? 2. Because it's 2 to the 4th, right? So this is really the 4th root of 16 times 2. How many there?
7.
There's 3 of them, right? I know that as a 4th root. What is it?
2.
2. And what did I leave under there?
8.
2 cubed, which is 2 4th root 8. Now stop for a second. I want you guys to see this the long way as well. Let's pretend you couldn't stop there because you didn't know 16 had a 4th root. So we keep breaking it down, yes? 2 and 8. There's another 2. 2 and 4. There's another 2. 2 and 2. There's another 2. 1, 2, 3, 4, 5, 6, 7. I need a group of how many? Group of 4. So I take out all 4 of them. There they are. And I left 3 of them. 2 times 2 times 2, which is 8. C is about the hardest thing I can ask you to do in the 10th grade. Notice I haven't asked you to do it by yourself yet. I'm going to stop for a moment and let you think about that. Are you cool with that? Please understand that it is the same thing as square roots. We're just looking for a bigger group. Is everyone okay? Are you asking me a question or stretching, Carlos? Okay. Is everybody okay? All right. We're going to do a couple more, then I'm going to shut up and let you go. We're actually only going to do 162 because it's a 4th, then I'm going to let you guys go on your own. How do I break 162 down? It ends in 2, so what can I automatically divide it by?
3 and 54.
I could do 3 and 54 because we've used this before, you little stinker.
We have.
Yeah, that was our LCM. Remember, our LCM in GCF was 54 and 162. I did that on purpose. Most kids usually say 2 and 81. Then what? 9 and 9. Then what? 3 and 3. 3 and 3. Do you see a group of 4 somewhere? Where is it? 3. 4th root, what did I leave under there? A 2. Everybody cool? All right. Now listen to me. I want for you to do E, F, and all of page 98. I do not want you to do 99. Look on the board, please. Tomorrow, I have scheduled you for a quiz. Remember, quizzes don't count, on exponents, which we did a few days ago. And all of you should already have made the connection between exponents and radicals. They work very closely together, don't they? Which is why I am attempting to see what happens if I make you try this by yourself on your quiz tomorrow. It might be okay, Tasha. Remember, you told me in grade 9 you couldn't do math and got a B. Okay? For F. Oh, one sec. I'm going to start coming around and helping with that. Okay? You do 97, the rest of 97, 98, and you know what? I will give, if you can try it and be honest and not Google it, I will give a gummy bear prize to anybody who can do 99. Yes, and you can't use a calculator. And you can't use a calculator. I am going to trust in your honesty that you don't Google it. Now, Josh, let's think about this for a sec. If all you want is some gummy bears and you actually Google it and then do the work, did you just learn something? Yeah. Did you just learn some math? Yeah. Who won? I win anyway, but you get some gummy bears out of the deal.
We are doing 97 to 99.
Try 99. See if you can figure it out. Let me give you this. There's a super easy way to do it. And if you don't figure it out, when I show you tomorrow, you're going to be like, damn, son!
No, no one will say that, Sam, because that's a dead meme.
Miss Myers.